Hey Honors Algebra 2 students, Mrs. Fellon. We are actually starting one of my favorite units, which is our trig unit. And so I'm actually going to start with page 244 of your student journals. There's a lot in this unit, and so you may want to grab some extra paper because I'm going to be kind of going in addition to what they're kind of showing you on these pages here, probably good adding some extra stuff. And you may want to have like a note page just of some important things that you want to kind of include or keep track of throughout the course of this unit. You also want to have a graphing calculator. So if you have all those things, great. If not, pause the video and gather some extra paper in your graphing calculator so that we can get started. All right, so first and foremost, what I want to remind you is that you've learned a little bit about trig in geometry, right? So you did some right triangle trig in geometry. And so let's just kind of refresh our memory. So we have a right triangle, right? So here we go. And what we learned in right triangle trig is that we have two different kinds of angles. These are our acute angles. So I'm going to call this theta. We use the Greek symbol theta. I probably would imagine that's not new to you guys, but that's what we would call this angle, right? Or you can call this angle theta. It's just like using a variable like x or y or whatever, but we're going to use Greek letters to represent angles. So in relationships, angle is how we kind of label our sides. So for example, if this is our angle, if this is the acute angle we're talking about, then the side opposite of that angle is then considered our opposite side. Makes sense, right? Side opposite the angle is the opposite side. The side that's next to the angle is called our adjacent side. And then the hypotenuse is always the longest side of your triangle, but also the side that is across from the right angle. And so if you remember, we did a lot to do with like sine, cosine, tangent, and then you probably haven't talked about cosecant, secant, and cotangent, so I'm going to introduce those to you as well. So what you probably learned about sine was that sine is the relationship, so sine of an angle. So like taking the sine of something is like taking the log of something or square rooting something. So it's an operation, right? So it's not necessarily, like you wouldn't just have sine by itself. So you're doing something to an angle when you do the sine of an angle. And so if you remember the SOHCAHTOA, so we use this little, these little symbols here to help us to kind of remember that sine is the relationship of opposite side over hypotenuse side. Cosine is the relationship of the adjacent side over the hypotenuse side. And tangent is the relationship of the opposite side over the adjacent side. So this is kind of how what you probably remember from geometry, right triangle trig. So if you did sine, you would call this like opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Tangent would be opposite over adjacent. What's probably new to you is what we call reciprocal functions, and that's cosecant, secant, and cotangent. So what I want you to know here is cosecant is related, I always call it like its cousin, is related to the sine function. So it's the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent, kind of, you can tell from just the name, right? Reciprocal of tangent. So you need to know which one matches which. So for example, you need to know that cosecant is always matching or goes together with sine. Those two are kind of together. They're cousins or however you want to word it. Cosine and secant go together, tangent and cotangent go together. Now, we use a lot of abbreviations, right? So like for sine, we use the abbreviation SIN. So sine of an angle might look like that. It's not pronounced sin, it's pronounced sine. Cosine, we use cosine of an angle, so cos, C-O-S, and then of theta. Tangent, we use tan. When we do cosecant, so what I would do here is cosecant is the reciprocal of sine. So instead of sine being opposite over hypotenuse, cosecant is hypotenuse over opposite. So literally the reciprocal. And then we use CSC to represent cosecant. right? So that's the abbreviation of cosecant. Secant's the reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And then this would be secant, so SEC. And then of an angle. Remember, you're not just going to have sine without anything next to it, right? Or cosine or tangent or even cosecant or any of the other ones. You have to have sine of something. So sine of an angle or sine of theta, whatever the case may be. Cotangent's the reciprocal of tangent, so we're going to do adjacent over opposite. And then cotangent is generally, the abbreviation is COT. So you do need to know these. So what I mean by that is you need to know that, number one, you need to recognize the abbreviations. You need to recognize, if you don't know SOHCAHTOA, you definitely need to know that. And then once you know SOHCAHTOA, then the reciprocal functions, as long as you remember that cosecant and sine go together, you're literally just taking the reciprocal of those particular functions. So down here you will see kind of it written out in words, like sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. You will also see the abbreviations, like cosecant is the reciprocal of sine, secant's the reciprocal of cosine, and cotangent is the reciprocal of tangent. So again, I want to strongly recommend that we know those angles, right? So we know those particular problems. Okay, so how we use this, and I'm just going to kind of go on a little bit of a tangent here. So I'm going to grab a sheet of paper. So what you probably did in your glory days of geometry, right? So you had a right triangle, and then you were probably given one of your acute angles. So like, for example, you might have been given this was 25 degrees. And then you might have been given that, I don't know, this is 12 and then this is x, and you were sent solve for x. So if you remember back in the glory days of geometry, what we probably did is we said, okay, well, this represents our theta. This is our angle. In relationship to this angle, this is the opposite side, right? Because it's the side that's across from that angle. This side here, since it's opposite or across from the right angle, would be called our hypotenuse. So what I always taught kids to do is, okay, if you've given this angle, you're provided with the opposite side and you're trying to find the hypotenuse. So what I want you to think about is what trig function deals with opposite side and hypotenuse. So remember, you have a couple of them. You have sine, that is opposite over hypotenuse. Or technically you have cosecant, which is hypotenuse over opposite. So you could use either one. Generally, we're going to probably go with sine just because that's probably the most familiar to us. So how we would solve this is we would set up a equation. So we'd say sine of our angle. So instead of calling it theta this time, we're going to call it 25 degrees because we named the angle. So sine of 25 is opposite over hypotenuse, so equals 12 over x. So remember, we picked sine because we were dealing with opposite and hypotenuse. If we were dealing with adjacent and hypotenuse, I would have picked cosine. So just remember that you're picking the correct trig function. What I normally do here is I cross multiply. So I set up a proportion, right? Fraction equals a fraction, and I cross multiply. Now again, do you have to do it the exact same way as me? No. So that's what I get, and then I'm going to divide both sides by sine of 25. What I want you to remember is that the sine of 25 is just a number. Kind of like log of 4 is just a number. Sine of an angle is just a number. All right, so there's a couple things that you need to make sure that you're going to do before you put this into our calculators. First and foremost, notice that this angle is written in degrees. So in your calculator, you have to have your calculator set at a certain mode in order for you to get the right answers, right? So what I want you to do is everyone can grab their calculators and I want you to check the mode. So if you hit the mode button, so see down here where it says radian and degree. You want to make sure that degree is highlighted. If it's not, put your cursor on it and hit enter because you want to make sure that your calculator is in degree mode. And so what that means is there are two different modes or two different units of measure for angles. One is a degree, one is a radian. And we're going to talk a lot about radians in a later video. But right now our angles are in degrees, so we want to make sure our calculator is in degree mode. And then to solve for x, you would literally just do 12 divided by sine, there's sine kind of in the middle, of 25, and I get approximately, it depends on how many decimals we round to, let's take it maybe just to 2, I get 28.39. So the length of my hypotenuse here would be 28.39. So that's probably, if you remember stuff about geometry in your right triangle trig unit in geometry, that's probably what you remember, right? Is that we solved a lot of sides, we solved a lot of angles, we did a lot of solving of triangles, and that's ultimately how we use our trig functions. And so that's what we kind of want to remind ourselves of today. All right, let's go back to our student journals. Let's look at page 243, which is right here. So there's some stuff on here that I want to kind of explain. It says exploring trig identities. So what a trig identity is kind of like a rule. Think about in geometry where you had like a postulate or a theorem, right? Those were your rules, so to speak. Same thing here. What we're trying to get at is that I'm showing you some things that are equivalent. So it says sine of theta is equal to the cosine of 90 minus theta. I want you to kind of visualize why this is true, right? So let's say we have a right triangle, and let's say this is theta. Well, we could represent this other acute angle. If this is 90 degrees, right? And then that means these other two angles have to add together to equal 90 degrees, right? Because there's 180 degrees total in a triangle. So we could represent this angle as 90 minus theta. Because whatever this angle is, to figure out this angle, you would just take 90 and subtract it from whatever this angle is. So if this angle was 20, then this would be 70 because it's 90 minus 20. If this angle were 45, you would do 90 minus 45 and get 45. So this angle and this angle are dependent upon each other. Now I could have made those angles in opposite positions. I could have put the theta here and the 90 minus theta here. Doesn't really matter. So what they're getting at is if you take the sine of theta, so here's theta, right? So if I took the sine of theta and let's call this 10 and let's call this, I don't know, 20. So sine is opposite over hypotenuse. So if I did the sine of theta, I would get 10 over 20. If I did the cosine of 90 minus theta, so that's talking about this angle here, would be adjacent over hypotenuse. They're showing you that those are the same thing. So the sine of one angle is congruent or equal to the cosine of the other acute angle, because you're still talking about the same side lengths. So sine of this angle is still talking about 10 over 20. Cosine of this angle is talking about 10 over 20. And so that's what we call a trig identity. So this is like something that's always going to be true. And same thing goes the opposite way. It's like if I did cosine of this angle, so let's call this, I don't know, 5, for example. So cosine of theta would be adjacent over hypotenuse. So I would get 5 over 20. Sine of 90 minus theta, so that's this angle here, would be opposite over hypotenuse. So notice how they're the same. So this is a relationship that's always going to be true, and so is this is a relationship that's always going to be true. And then the other ones here are just kind of talking about the reciprocal functions. If sine is opposite over hypotenuse, cosecant would be the reciprocal of it. So if I wanted to do cosecant of theta, I would do, instead of doing opposite over hypotenuse, I would do hypotenuse over opposite. So it's literally just taking the reciprocal. And that's what that is too, except dealing with tangent. What we're also wanting to make sure is that there's a couple other trig identities that I think are worthwhile knowing. So what this pertains to is sine squared plus cosine squared equals and then blank. So what we're getting at here is, again, a right triangle, because that's what we're dealing with here, and most of our trig stuff is dealing with right triangles. So let's say I did, let's say this is theta, and let's call this, I'm going to use one of our special right triangles. So if you remember the special right triangles, which are the 30, 60, 90, or the 45, 45, 90 triangles, I'm going to use one of those. So anyways, I'm going to label my side lengths as 1, 2, and then root 3. If I did sine squared, okay, so sine is the relationship of opposite over hypotenuse. So if this is my angle, my opposite over hypotenuse would be 1 over 2. And so if I squared it, I would get 1/2 squared. Plus, so cosine of this angle would be adjacent over hypotenuse. So it'll be root 3 over 2, and then we're going to square it. What is this going to equal? Well, 1/2 squared is 1/4, because 1/2 times 1/2. Root 3 over 2 squared, root 3 times root 3 is just 3. 2 times 2 is 4. What's 1/4 plus 3/4 is 1. So what I'm showing you here is any time, and it doesn't matter if this is, if I use if I use this relationship or if I use another equivalent relationship. If I take the sine of an angle and square it, and add it to the cosine of that same angle and square it, the relationship is always going to equal 1. So sine squared plus cosine squared is always going to equal 1. What's also true is secant squared minus tangent squared is also going to equal 1. Let me show you. So remember, secant's the reciprocal of cosine. So if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So I would do, if I go back to this triangle, hypotenuse over adjacent would be 2 divided by root 3. And I'm going to subtract this time, and then tangent of my angle would be opposite over adjacent. So that would be 1 over root 3. So let's simplify our answers here. So 2 over root 3 squared would be 4, and then square at the bottom, which would be 3, minus 1 over root 3 would be squared would be 1 over 3. 4/3 minus 1/3 would give me 1. So what I'm showing you here is these are two other trig identities that are rather important that are going to come up over and over and over again. So again, the relationship of a secant of an angle squared minus tangent of that same angle squared is always going to equal 1. And so we call those trig identities because, like I said, they're like theorems or rules, kind of like what we did in geometry. Those are some of the rules for trig. If we look down here at number 3, it says, how can you find a trig function of an acute angle, theta? So what we're asking you to do here is basically say, if I'm asking you to find a trig function for an acute angle of theta, I'm just asking you to kind of write the relationships. So like sine would be, any of these, you could do sine of this angle here or sine of this angle here. And so when you ask to write your trig, the ratios or the relationships for your trig functions, I'm just asking you to write like sine of your angle equals opposite over hypotenuse. A lot of times we'll say write your 6 trig functions, which just basically means you're going to do sine, cosine, tangent, and then cosecant, secant, and cotangent. So this would be the 6 trig functions. So that's kind of in generic terms, right? So that's just using O's and H's and A's and all that kind of good stuff. If we give you a specific example, like use a calculator to find the x and y for the legs of the right triangle. So like for example, if I had this angle here, technically I could find this angle here, because remember this angle is 90 minus theta, which in this case would be what, 65? Because we knew that those two angles had to add up to equal 90 anyway. So technically you could use 65 if you wanted to, or you could just stick with the 25. So pick an angle. So in this case, I'm going to pick the 25. X in relationship to the angle 25, this would be my adjacent side, this would be my hypotenuse side, this would be my opposite side. So in relationship to this angle, this is my adjacent side, opposite side, hypotenuse. So if I wanted to figure out the value of x, and x is dealing with adjacent, and I know my hypotenuse. Adjacent hypotenuse is cosine. So what I would do is I would set up cosine of 25 is adjacent over hypotenuse. I would cross multiply. So I'm going to grab my calculator and do cosine of 25. So cosine of 25. Again, I'm in degree mode, so I'm good. So I got 0.906 equals x. And then if I wanted to figure out y, I could still use this 25-degree angle, or I could go back to 65, it doesn't matter. But in relationship to the 25-degree angle, this is my opposite side, And now I would still stick with my hypotenuse because I was given that as to be 1. So if I was to pick a trig function to be able to solve for y, this is opposite in hypotenuse, I would pick sine of my angle, so sine of 25 is going to equal opposite, which is y, over hypotenuse. So cross multiply, so sine of 25 is 0.423, and then y. So that's how you would solve for those missing pieces there. All right. Let's move on to page 242. We're kind of jumping around a little bit here, which is okay. Trying to cover all of our bases. All right, so this is kind of a nice little page here because it kind of highlights all of the different trig functions. And so again, it shows all your ratios again. So if you're interested in just kind of, memorizing these, I do strongly recommend, if you don't know them, that you're going to want to go ahead and know them. So these, what we're talking about here is what we call special right triangles. This is something else that you probably should have learned in geometry. So if you didn't learn this in geometry, well, then this is going to be our review. So there are two special right triangles, and one is a 30, 60, 90 triangle. A lot of times you see it written kind of like this. And then you have a 45, 45, 90 triangle. So hopefully these are familiar to you. What's special about these triangles is, number one, this is what we're going to be using a ton of in this class, is we're going to kind of be diving into these special right triangles and how we're going to use them in something called our unit circle. But in these special right triangles, what we're getting at is there's a relationship between all the side lengths. So you might have learned that there was a relationship between what we call short leg, long leg, and hypotenuse. So just as a recap, I'm going to go ahead and go over those. So for example, if this is my 30-degree angle and this is a 60-degree angle, if this is a smaller angle than this one, then the side across from it has to be my smaller side length, remember? So like the lower the angle or the smaller the angle, the smaller the side length across from it. So I'm going to call this my short leg, and I just use the abbreviation SL, so I call it short leg. This is my hypotenuse. I'm going to put like a big H there. And then this is going to be my long leg because it's across from a larger angle. So there were some relationships that I need you to remember in a 30, 60, 90 triangle. So I'm just going to write them down here. And so these are the relationships I want you to remember. From the short leg to the hypotenuse, what you do to get from 1 to 2 is you multiply by 2. And so we used 1, 2, and root 3 as kind of our standard, but if we use different numbers, no matter what this number is, if this were 10, to get to the hypotenuse, then this would be 20. You would multiply by 2. So how I kind of remember it is I go from short leg to the hypotenuse, we multiply by 2. So I'm just going to kind of write down the relationships. From the short leg to the long leg, so short leg to long leg, we multiply by root 3. So to get from 1 to root 3, we multiply by root 3. Okay, so hopefully those sound familiar. So there's a relationship between the short leg and the hypotenuse and the short leg and the long leg. There's really a real specific relationship between the hypotenuse and the long leg. So we just kind of use these two as kind of our go-betweens. Now, since you have those two, you can also go the other direction, like hypotenuse to short leg. So if you're going backwards, from here back to your short leg, instead of multiplying by 2, you would divide by 2. And then same thing goes with the short leg to the long leg. If you're going from the long leg back to the short leg, you would take the long leg to short leg, you would divide by root 3. So those are going to be the relationships that we're going to deal with in so those are going to be the relationships we're going to be kind of talking through. So I want us to kind of remember. So this is all from geometry. Hopefully this is not brand new stuff, but if it is, this is what we're kind of looking at. All right, let's do the 45, 45, 90, and then I'll show you a couple examples of how maybe you would see this. So 45, 45, 90 triangle. So notice in a 45, 45, 90 triangle, both of those angles are 45 degrees, right? That's why they call it that. And they're equal, which means the sides across from them have to be congruent. So think back to your geometry days, right? So if these two angles are congruent, then those two sides are congruent. We call this an isosceles triangle. All right, so we call this the leg of a triangle and leg of a triangle, and this is the hypotenuse. The reason why we don't call short leg and long leg, because they're the same length, so we don't really have, a short or a long. All right, so to get from a leg, either one, to the hypotenuse, so leg to the hypotenuse, you would go from 1 to root 3, 1 to root 2, you would multiply by root 2. So to get from one of the legs, either one, doesn't matter, to the hypotenuse, you would multiply by root 2. Now, to go the other direction, you would go from hypotenuse back to leg, you would divide by root 2. So, leg to hypotenuse, multiply by root 2, hypotenuse to leg, divide by root 2. All right, let's do a couple examples of where you might see something like this. All right, so let's say I gave you a right triangle. Okay, so this is our hypotenuse, right, because it's across from the right angle. This is our short leg, this is our long leg, and so we're going to make this the 30-degree angle and this the 60-degree angle. Because obviously the short leg has to be across from the smaller angle, the long leg has to be across from the larger angle. All right, so now what if I gave you, and I said, okay, I'm going to use a pencil here so that we can kind of change some of these as we go through. All right, so what if I said this length is 7, and I said find the other lengths of your triangle. So if you're given the short leg, remember you have some options. Let's say you wanted to figure out what this length is and what this length is. So from short leg to hypotenuse, remember, you just double it or multiply by 2. So this would be 14. From short leg to long leg, the relationship is you multiply by root 3. So this would be 7 root 3. So that's how you would use those relationships to kind of help you figure out the other pieces of the triangle. All right, so now I'm going to erase this. And we're going to go, and now I'm going to give you something else. What if I give you that this is 100? So the hypotenuse is 100, and I ask you to find the other two legs of the triangle. So now you would, since you're given the hypotenuse, you're going to use a relationship that you know with the hypotenuse. So the only one you really know is the relationship to the short leg. So from hypotenuse back to short leg, so if we're going the opposite direction, we're going to divide by 2. So that means this is 50. From short leg to long leg, we're going to multiply by root 3. So we get 50 root 3. All right, let me give you the last scenario. And this one is where we are given the long leg. Let's do 3. Okay? So we're going to use some radicals here, and so that's why we're going to be doing some practice with this. All right, so if we're going from long leg, the only relationship we know is from long leg back to short leg. So to go from long leg back to short leg, we would divide by root 3. So we would get 3 divided by root 3. Now, we don't want to leave our answer like this because there's a radical on the bottom. So this is where you would rationalize. So you would do root 3 over root 3. So remember, rationalizing means you're going to get rid of that radical on the bottom. So on the top, I would get 3 root 3. So 3 times root 3. And then root 3 times root 3 is just 3. Simplify it more. What's 3 root 3 over 3? Well, guess what? The 3's cancel out. You're just left with root 3. So again, all we did here was took this 3 and we divided it by root 3 and we just simplified our answer. So all of this was just simplifying. All right, now that you know that this is root 3, get to your hypotenuse, you multiply by 2. So what's 2 times root 3? Well, it's 2 root 3. That's it. All right, let's do the 45, 45, 90 triangle. Same kind of deal. Okay, so clearly this is our hypotenuse, these are our legs, right? So let's say, for example, I tell you this is, 20. Obviously, this other leg would have to be 20 as well, right? Because they're congruent. To get from a leg to the hypotenuse, either one, you would multiply by root 2. So this would be 20 root 2. All right. Again, let's say I switched it up, and let's say I told you this was, I don't know, 40. And I said, okay, the hypotenuse is 40. Find the legs of your triangle. To get from 40, to get from the hypotenuse back to your leg, you would divide by root 2. So 40 divided by root 2 looks like that, but we're going to simplify. So I'm going to do root 2 over root 2. So I get 40 root 2 over root 2 times root 2 is just 2. And then I'm going to simplify this to 20 root 2. And then, of course, if that's 20 root 2, so is that. So that's kind of your, like your relationships as a review of what you did in geometry. So hopefully this isn't like brand new stuff, but I wanted to at least give you kind of a heads up of some of the relationships that we're going to get into. All right, I want you to jump ahead to page 245. So there's this lovely chart here, which is kind of nice. And so this is your 30, 60, 90 triangle. And so what they do here is they say, okay, if we're going to go ahead and do our 30, 60, 90 triangle, do our standard, like if this length is 1, the hypotenuse is 2, and this is root 3, this would be the sine of 30 degrees is opposite over hypotenuse. That's how they got 1/2. The cosine of 30 degrees would be adjacent over hypotenuse. That's how they got root 3 over 2. Tangent of 30 degrees is opposite over adjacent, which is 1 over root 3, which again then reduces to root 3 over 3. And so what they did here is they just kind of did all of the trig functions for all of those triangles. We're going to get into a lot more of that in a little while, so I'll kind of move on. I want to go over a couple different examples. So example 1 will say something like, evaluate the 6 trig functions. So there are 6 trig functions, right? Sine, cosine, tangent, cosecant, secant, and cotangent. So I'm going to give you a right triangle. And I'm going to tell you this is theta, and I'm going to tell you this is 24, and I'm going to tell you this is 7. And that's all I'm going to give you. I'm going to ask that you find the 6 trig functions. So what that means is I want sine, cosine, tangent of your angle. So again, we don't know what our angle is. We're just going to call it theta. And then cosecant, secant, and cotangent. So we want, those are the 6 trig functions. All right, so in order for us to do this, we need all of 3 sides of our triangle. If this is 7 and this is 24 and this is a right triangle, you learned a formula that we need to be able to remember to be able to figure out this last side of the triangle. So that formula is called our Pythagorean theorem. So if you remember Pythagorean theorem, we would go a squared plus b squared equals c squared. So let's do the Pythagorean theorem to figure out the hypotenuse of this triangle. So I get 49, and then 24 squared is 576. So this would give me 625 is c squared. And then I'm going to square root both sides. 625 is a perfect square. Technically, you would get plus or minus 25, but since we're talking about the length of a side of a triangle, it can't be negative. So we're going to say that that is 25. Once you know this side, you should be able to figure out all of your ratios. So sine is opposite over hypotenuse. So if this is my angle, 24 is my opposite side. 7 would be my adjacent side. And 25 would be my hypotenuse. Again, it's all in relationship to whatever angle we're talking about. So if this is my angle, this is my opposite side, adjacent side, and hypotenuse. So then sine would be opposite over hypotenuse. If you can reduce that answer, reduce it. In this case, it doesn't. Cosine would be adjacent over hypotenuse. Tangent would be opposite over adjacent. For cosecant, secant, and cotangent, you can just look back at these and then just do the reciprocal. So for cosecant, the reciprocal of sine would be 25 over 24. The reciprocal of secant would be cosine, so that'd be 25 over 7. And the reciprocal of cotangent, tangent is the reciprocal of cotangent, so that would be 7 over 24. All right, let's see if I can squeeze in another example here. So example 2. what it would read is, in a right triangle, theta is an acute angle. Okay. And sine of theta is equal to 5/6. Evaluate the other trig functions. So what that means is I'm telling you what sine is. I want you to find all of the rest. So I want you to find cosine, tangent, cosecant, secant, and cotangent. So I want you to find all of the other ones, okay? So this is what I would recommend that you do. So if you're given any trig function, whether it's sine or whatever, draw a triangle, okay? Label where theta is, and it really honestly doesn't matter if you put it here or here. So you pick. So I'm gonna put it down here, just for fun. And then if sine, since I'm given sine, this has to be my opposite side, this has to be my adjacent side. So what I'm gonna do is I'm gonna label my opposite side of this angle as 5 and my hypotenuse as 6. So essentially what I'm giving you is a different variation of this problem here. I didn't give you the picture with all everything, so you had to use this information to draw your picture. But the process is still the same. Use Pythagorean theorem to solve for your third side. Be careful, remember, this is your hypotenuse, so you would go 5 squared plus b squared equals 6 squared. And then subtract, I would get the square root of 11. So I get this side to be the square root of 11. Now that you've used Pythagorean theorem and figured out your third side, now you can go ahead and do your ratios. So cosine to this angle, so cosine would be, this would be my adjacent side, this would be my opposite side, this would be my hypotenuse, again, in relationship to that angle. So I would get, cosine would be adjacent over hypotenuse, so root 11 over 6. Tangent would be opposite over adjacent, so 5 divided by root 11. So you would need to rationalize here. So multiply both the top and the bottom by root 11. So I get 5 root 11 over 11. Cosecant's the reciprocal of sine. So if sine was 5/6, then cosecant is 6/5. Secant's the reciprocal of cosine. So this would be 6 over root 11. But again, you would have to rationalize that. So multiply the top and bottom by root 11. So you would get 6 root 11 over 11. Cotangent's the reciprocal of tangent. So tangent is 5 over root, I always kind of look back at the original one. So tangent is 5 over root 11, so cotangent is root 11 over 5. And so that's how you would find the rest of those trig functions, only given one of them. And again, I could have given you sine or cosecant or any of the other trig functions, cosine or whatnot. And then you would have used that to kind of build your triangle, use the Pythagorean theorem to fill in the missing side length, and then once you have that, you can write your ratios. All right, we're going to be doing a lot more practice. The videos in this section are probably going to be a little bit longer only because there's just a lot more information. And I want to make sure I'm thorough so that way you can kind of go back and rewatch these as needed. This is a very important unit, and so we want to make sure that we're understanding. And so if you're at all lost along the way, please make sure that you reach out to your teacher and ask. It's really important that you are staying up to date and that you understand what's going on. All right, practice, come to class with questions, and I'll see you next time.